All right, so for our next issue here, it says example 2, divide any y value by the previous y value in the sequence to find the growth or decay factor b for each exponential function. You'll need the y-intercept a. Write an exponential function that models these values. All right, so this first question is actually a little tricky. I tried to stump you, so you understand what I'm talking about here. So if we take a look, now this should really sound like our geometric sequences. If our first number in our sequence was 6, our second number was 18, our next one was 3, then these were the numbers in our sequence, and we could take any number. All right, so b is going to be any number. The 18 would be great, divided by the previous one, and we get 3. So that's our value of b. I also forgot to answer, is this a growth or decay function? Well, we can see the numbers are growing, the y values are increasing, so this is growth. Then we want to write our function. So the problem is that a now is the y-intercept. It's not the first value in our sequence. So we have to ask ourselves, what would 0 be? So what would the y value be at 0? And that's not too hard to do because we've learned this before. If we want to go back one value, we would divide. So our a, our initial value, is actually going to be 2. So our x value would be 0. Our initial value is 2 because 6 divided by 3 is 2. So a equals 2. And now I'm ready to write my function. So my function is f of x. My initial value is 2 times 3. And this is just raised to x. Notice we no longer, when it's a function, use the minus 1. What the minus 1 is doing is it shifts it from starting at 0, then instead it starts at 1. So that's the difference between a function and a geometric sequence. Right? So let's go ahead and see, what do you guys think about b? What do you think is this one? Is this one growth or decay? Is it increasing or decreasing? Can you tell me what the initial value is? Hint, I already gave it to you. And can you tell what the rate of change is? So that's going to be the tricky question. All right, so I've got 3 questions for you, so let's see if you can answer them. If you did it correctly, you would have said this one is decay. The y values are definitely decreasing. My initial value, which is a, is always happens when x equals 0. It's your y-intercept. That's 100. And b is going to be, remember, you take any value and you divide it by the previous one. So 25 divided by 100, and then this equals 0.25. So your function is going to look like this. F of x equals initial value, 100, times, you can use parentheses for emphasis, 0.25 raised to the x. And that's how you write an exponential function. All right, let's look at a couple more examples just so you can piece apart a function. For each exponential function, determine the initial value of the y-intercept, so that's also known as the y-intercept, the rate of growth or decay, which is b, so it's actually going to find a, b, but then c, what would the value of c of 5 be? So you'll need a calculator. If you don't have a calculator close, go ahead and pause the video and go grab one. For A, part A, the initial value, that's always going to be the first number you see, so it's 0.4. B is going to be 3, that's the rate of change, so it's whatever is being raised to the exponent. And C, it asks for f of 5, so that we're just going to plug in 5 wherever we see an x, so 0.4 times 3 raised to the 5. And grab your calculator. I've grabbed my calculator. You can see that I got 97.2 when I typed that in. So 97.2. All right. I'm going to have you guys go ahead and try those next 2 on your own and remind me to finish those up in class. We got one more video so that we can take a look at some word problems because these are very popular word problems. So we'll show you how to break those down and make them a little bit easier.